Good evening, everybody. Welcome to the BRLSI, those of you who are here for the first time. This is a meeting of the science group of the BRLSI, although I don't know about you, but I certainly have the impression that in the new BRLSI era, actually the identification of particular series of talks is of less moment than it used to be. But indeed, I am the convener of the science group. My name's Stuart Reynolds. And so I thought I'd begin by telling you that we have a meeting that's quite relevant to likely your interests coming up quite soon on Thursday, the 4th of April, if you'd like to make a mental note of that. It's called Growing Buildings Sustainably, and it's actually about how to make houses out of straw. And you'd be surprised how much of a science and technology subject that is. Our speaker this evening and I were talking about the story of the three little pigs earlier on, and it's not relevant at all to the talk.
The university, when they built the straw house for demonstration project, they had a big bad wolf test, checking how it would fare with
Yes.
So it is relevant.
Yeah, very good. Right, so we're very lucky to have this evening my very good friend Philippe Blondel from the Department of Physics in the University of Bath, and he's going to talk to us about climate change in the Arctic, a topic that, as he will rapidly realize, is of great moment to us who don't live in the Arctic. Philippe, as you'll soon hear, is a native of the Republic of France. He comes from Normandy. His first degree was from the University of Rouen in Normandy, and after that he migrated to Paris, where he worked, if I can remember this correctly, both in the University of Paris 7 and also the University of Paris 11. Doubtless, if anybody's really interested in that, they can talk to him about it later. After that, he saw the light and migrated to the Anglophone world. And after a postdoc at the University of Washington in Seattle in the United States, and via another research job at the University of Southampton, he eventually arrived here at the University of Bath, where he's been entertaining us ever since, to his interests in the sounds of the world around us. And he's particularly interested in the sounds in the sea, in the Arctic, and he's going to tell us all about it tonight.
Okay, thank you, Stuart, for inviting me. Thanks to the science group. And thank you all for braving the dark and stormy night outside, the rain, the wind, the falling branches, coming to learn about climate change and talking about what's happening in the Arctic. I'm going to talk about it from the perspective of a physicist, because that's where I'm based. I've been in the Department of Physics at Bath for 25 years. And I've had, and I have the pleasure of working with some of you at the moment. I'm going to talk about the intersection of physics, geophysics, and the environment. Having truly integrated, even if I haven't lost the accent, I have all these initials after my name. So I worked with geophysicists for a long time, which means I'm a chartered geologist and a fellow of the Geological Society, a fellow of the Institute of Acoustics in the UK, based on what I've done with sonar. And because we all do research and teach, I'm also a fellow of the Higher Education Academy. And climate change in the Arctic is important because this is what we're experiencing now, climate change, and what happens in the Arctic doesn't stay in the Arctic. First, yes, we might miss some of the titles at the top, but that's not that important. What is important is the 200th birthday of the BRSI. So happy birthday to all. That's great, that's perfect. And we can look at the past, think about what everybody at the BRSI has done for the last 200 years. If you have the occasion to see some of the collections, it's really worth it. But we can also look at the future. What will be the BRSI in 200 years? What's going to happen? And what's going to happen in the world around us? This diagram there shows the world from 50,000 years ago, 10,000 years ago, so when we had mammoths, giant carnivorous kangaroos, how it was slowly settled, how it accelerated within the last 150 years up to the present, how we think it's going to pan out in the coming century. So hopefully a good version like that with green and sustainable architecture, and compare that with what's happening in the oceans. The oceans were untouched for a long time, just with small vessels, sailboats. Then we had industrial activities. And it's only in the last century that things have changed in the oceans, and they are changing, and they have changed very fast. Now we're talking about marine renewable energies. We're talking about aquaculture. We're talking about shipping all around the world, including the Arctic, using all the resources from the sea, and even building cities in the sea as well. So we have to think carefully about what kind of future we want, what kind of present we want, and how we can use science for that. And the big issue is climate change. Climate change is happening. On the left, we have the healing curve from UCSD, the University of California, and that's the poster plot of what's happening with the climate at the moment. So it shows the amount of CO2 in the atmosphere for the last 10,000 years, and how within the last 150 years, it climbed up very fast. That means that it's changing the content of the atmosphere, how much heat it can absorb. That's leading to global warming. And that's something we can see in the Arctic very well. In the Arctic, the temperatures are rising 3 times faster than in the rest of the world. Some places that I've been to, I've been there in summer. Usually you would expect temperatures of -10. It was +5, which is a bonus if you're out during most of the day, but not something good for the environment, good for the animals. And there have been other places where the temperatures have risen a lot in the last years. For example, in Greenland, some of the glaciers on the west coast have started to melt enough that some of the local communities can actually grow gardens and strawberries in their gardens. Strawberries from Greenland, we're not going to see them in Sainsbury yet, but that's one of the effects of climate change. But that's going to affect all the animal species and everything. So these plots there show what is happening between 1917 and 2018. This is the temperature change in degrees per decade. So how all the Arctic there is actually warming up. This is the sea ice. So how the sea ice is, of course, melting during the summers when it's warmer, and how the content of ice that we have at the North Pole and around is actually decreasing little by little. And at some point, we think it's going to disappear totally. So this melting snow, this melting ice have effects on local ecosystems, but they also have effects on the global climate system. They're going to contribute to rising sea levels because all the water, what was in the ice cap, is going to be released. It's going to be like the end of the Anthropocene 10 years ago, with the big glaciers melted. So all this water is going to go somewhere. That's going to create sea level rise. Some places are going to have more sea level rise than others because of ocean circulation. Some cities like Amsterdam are preparing very actively for it. You can have apps that tell you based on the rising sea levels and the tidal surges where you can go to be safe. Other cities have tidal barriers, London, Venice, but they're going to be feeling the brunt of these sea level rises. And we see the coastal erosion, we see some villages being evacuated in Wales, all sorts of effects already now. This temperature is not going to be only in the Arctic, it's going to go down. That's going to affect the weather systems. That's going to create what's called extreme temperature events. For example, when the winds at the separation of the Arctic and the more temperate latitudes, when this separation is moving south, that's creating the Arctic blasts that we have during winters, and we had more of them recently, or otherwise it's going to keep the weather more rainy in some parts of the world. In others, it's going to affect, for example, the monsoons. That's why lots of research agencies from India, Korea, Japan, China are very interested and working in the Arctic to understand how it's going to affect the future weather. So these effects are going to be felt all across the latitudes, not only the high latitudes, but below there as well. That's going to have lots of effects on the environment. For example, if we have less water, if we have issues with irrigation, farming, just drinking water, economic implications, social implications, if suddenly we have millions of people in a dry country, how do we deal with that? So there are lots of issues there. And we know what it is because we have lots of measurements from all around the Arctic. We have reports from the Intergovernmental Panel on Climate Change, the IPCC. Every 5 years, they produce reports about everything we know, and they give an indication of how well we know or what is still a bit undecided and what is absolutely terribly sure. For example, this is the report published a few years ago about polar regions. It was written by 200 experts and reviewed by even more people. I was one of the 400 people who reviewed it. So we know for sure that what we have is really the scientific consensus. So the experts are unanimous. Even if Michael Gove tells us we don't need experts, the scientists who spend their lives studying one thing know what it is, they have the numbers, they can show what's going on. This year, we are part of the United Nations Decade of Ocean Science for Sustainable Development. So it's taking more measurements and trying to work out for a common good, the common good of the people, the ecosystems, the animals, and the common good of the planet as well. And all the different climate scenarios that we have explain the importance of the Arctic oceans based on how much CO2 we have, how much heat the oceans absorb, and we can try to aim for these different sustainable development goals that were set by the United Nations. For example, goal 14 is about the oceans and life underwater. We have the climate, energy, and so on. My colleague, Jonathan Dawes at the University of Bath in the Department of Mathematics has looked at how interlinked they are and actually found out that some of these sustainable development goals are critical points. If we act on them, we can act on all the others. And I'm very pleased that the things I work on are all in the nexus there. It's not me saying it, it's the mathematicians, but at least it justifies how we can have broader actions by looking at these different places. So the Arctic, what does it look like? This is a polar projection. So what we have is the North Pole at the center. It's like looking from the top of the Earth, and we see different countries. We see Greenland, we see Norway, Iceland, Svalbard, which depends from Norway, Novaya Zemlya and the Russian coast there, going to Siberia, Alaska, Canada, all the way there, so the Arctic Canada, Nunavut, and other places, and some of the Baffin Bay and Baffin Ocean and everything there. What is important is that the central Arctic Ocean is very deep, more than 4 kilometers in some places. It's very flat. We have a ridge in the middle, the Lomonosov Ridge. We have a spreading center, a mid-ocean ridge there, the Gakkel Ridge, which is an ultra-slow spreading center, but it's still there, it's still creating new crust. And everywhere we have sediments which are around 1 kilometer thick on top of all the old crust. We have very extended continental shelves there. These continental shelves are important because they provide more nutrients to the animals, but they also provide means for different countries to extend their economic exclusive zones. And there are competing claims from all the countries around about how much of the Arctic Ocean they can claim for their own countries, for their own resources. This bathymetric compilation is based on lots of measurements from everywhere. It took around 20 years to produce. But when we sail there, most of the time it's going to be covered with ice, especially around the North Pole there. The water that we have is a big mix. We have Pacific water coming from the Bering Strait into the Chukchi Sea and around there, mixing around. We have the Atlantic water that comes in as well through the Fram Strait between Greenland and Svalbard. It's very complex, more complex than what the graph shows. So we have drifts around, we have gyres where we have just big whirlpool, hundreds of kilometers wide. I have a colleague in Poland who put a buoy to measure the oceanography in this place. And in one of the places, it's been stuck for 10 years, moving around and not getting out. So these systems are quite stable. Well, at least geographically. Inside, the big problem is how much heat they bring. For example, if the Atlantic becomes warmer, it's going to bring warmer water to the Arctic. It's not going to be able to cool it as much, and that's going to affect ocean circulation as well. So right now, we can already see some changes in what's happening in these water masses. In some places, we can see that the oceans are warming up to 200 meters down in some places. At some point, they won't be able to absorb more heat, and this heat is going to stay in the atmosphere. So that's going to amplify everything that we see right now. Life in the Arctic Ocean is varied despite or because of the ice. We have all sorts of interesting animals. We have belugas. That's some of their habitats there. The only ones I saw were around Svalbard, and everybody was very blasé saying, oh yeah, belugas, yeah, I've seen them. But they're still magic. There are narwhals, bowhead whales, ringed seal, walruses, polar bears, they're everywhere. Especially as soon as there's ice, they use that. Some of the animals use, for example, the polar bears walk on the ice and they walk around. They can migrate from countries. They can raise their young there. Seals use that as a base to give birth and for the youngs. Bowhead whales break through the ice or try to get a place with no ice to breathe before diving down again. So the ice, what it's made of, whether it's thick ice or thin ice, whether it's stable or not, everything is very important to all these animals. But they are threatened from climate and from human activities. The resources that we have in the Arctic Ocean, we have large oil and gas reserves. So that's going to be, that's a map that was compiled by the WWF, but it's based on USGS reports from the US Geological Survey. We see Greenland there. We see where the main deposits are, where people think about future developments, for example, on the US coast, and it stops right there at the Canadian coast. It can be oil and gas. It can be fishing grounds as well. All this is going to be of interest. At the moment, there is no exploration or drilling for oil or gas in the high Arctic Ocean. There is a moratorium on fishing in the Central Arctic Ocean for 16 years, but we have a lot of incentives to go there when we run out of resources, we run out of oil, we run out of fish. Some people might be tempted to go to these places. And that's a map of some of the deposits there. So the US Geological Survey analyzed that 13% of the world's undiscovered oil and 30% of the undiscovered gas is actually around the Arctic Ocean. In 2018, there was a major deposit found in the Barents Sea And we know there are more waiting to be discovered and getting more and more tempting to exceed. The other issue is Arctic shipping. With the melting of the ice, we can actually access the Northwest Passage and the Northern Sea Route. The Northwest Passage is north of Canada, north of Alaska. It's joining the Atlantic Ocean to the Pacific Ocean, cutting days or weeks of shipping time to access different markets. Explorers for centuries have died most of the time trying to find the Northwest Passage. But now, with the melting of the ice, there is more and more traffic going there. The Northern Sea Route is along the coast of Norway, Russia, and reaching China and other Asian markets as well, hugging the coast there. These routes are much more busy now. We have the potential for trans-Arctic routes by 2050, going through the Arctic in summer when the ice has melted. And the issue is not only the pollution, oil spills, search and rescue. I was talking with some coast guards in Norway, and they say as soon as you're north of Svalbard, you have to be able to survive for at least 2 or 3 days before anyone can reach you, if they know where you are and how to find you. Otherwise, you're stuck there. If your ship starts leaking oil, well, you have to hope that someone can come and help you. There are more harbors being built in some places, military bases as well to control the traffic. And all these ships create noise, so they create pollution from their chimneys. They can create pollution from oil spills, but they create noise, especially underwater. And this noise can propagate for very large distances. This is from measurements at lower latitudes around the US. We see the tracks of ships and how much noise they create. So blue is the background. Some of them are fishing, others are moving at different speeds. And that's creating what's called an acoustic footprint. It's like being next to a motorway, having the traffic over time. Not only can you hear it over time, it's going to prevent you from talking. It prevents the animals from communicating. So most of them rely on sounds to find their prey, and they won't be able to do that. If the sound is loud enough, it can also injure them or even kill them. We have models of how sounds propagate underwater. There's an article by my friend Kevin Heaney, who published it just a few months ago. That's just models for one frequency, but it shows how just the current shipping is actually creating a lot of noise in large parts of the Arctic. So that's things to think about. Some of these ships use instruments, for example, to explore for oil. I have a colleague, Aaron Fott, who works in Alaska and the Chukchi Sea looking at waves. And once he could hear a seismic vessel going bang, bang every 10 seconds, being very loud. He was very upset because he was in a marine protected area. No drilling or exploration was allowed. And he was able to track the sound of a ship to a place north of Norway, not even in the Arctic Circle. So it was a perfectly legal use of a ship, but the sound was actually propagating all the way across the Arctic Ocean to the other parts. So that's another thing to remember, is what we do in one part of the ocean is going to affect all the others. So these sounds, we know what they are. If we look, this graph is called events curve, this compilation that has been added to since 1948. And we have the frequencies on the horizontal axis, 1 hertz, 10 hertz, 100 hertz, then moving into kilohertz, ultrasounds. And that's the noise levels, the sound levels. That's the background from the sea. In blue, we have the different sea states. As the sea is more agitated, of course, we're going to have more wind, more waves. All these waves crashing are going to make more noise. In some places, we're going to have the noise from ships, from animals, from rain falling, all sorts of things. So it's definitely not the world of silence that Jacques Cousteau was talking about, but we can make good use of these sounds to understand what's going on. Sound, for the last 2 years, has been declared an essential ocean variable, something that we should always try to measure when we deploy instruments at sea, and we use passive acoustic monitoring. So it's a good way to get the acoustic signatures of marine life, human activities, understand what they are. In some places, have been places where we have a flat sea, nothing at all, just a glacier in the background, and the noise underwater is equivalent to sea states 4 or 5, so very agitated weather, just because of the noise from glaciers and the noise from the ice. So there is still a lot to understand and to look at. So we use ocean observatories and field surveys. Field surveys are often called cruises. And when I started in Bath, my colleagues in physics were looking at me very strangely. First, because I was traveling to exotic places. Some of them were very happy to go to Manchester. I have nothing against Manchester, but it's not that exotic for me. So I've been on ships like the Marion Dufresne, the French Antarctic vessel. It's so big, but it actually can hold small vessels inside the hold. And it goes to the Antarctic every year. So long cruises, exotic locations, exploring the 7 seas, marine activities, everybody knew what it was. So once I realized that, I had to disappoint them and say, well, it's a bit less glamorous. This is what we dress like. Actually, that was in the Arctic. So the orange suit is completely zippable all the way, and you have the hood and you have the gloves. The first time I had an Arctic suit, it's very complete. And I had chosen the wrong size. It took me 10 minutes with pliers to get out of my suit afterwards. To add to the glamour, you have a rifle there against polar bears or other animals, because all the animals in the Arctic, if you're not a prey, you're a predator. Whatever you are, they're going to attack you. Even the seagulls do attack. And that's why I have a helmet in my office against the seagulls, for example. So exotic locations, yes, it's very exotic. Sometimes the weather is bad like that. So you're not allowed on deck, or you have to go out roped to someone else, and you have to tell the bridge when you come back. In terms of other activities, yeah, deck activities, sometimes you have to deploy instruments in freezing water, hoping you're not going to bash anything on the way in or on the way out. And you come back, and the only thing you want to do is have a hot drink and rest for the next 8 hours. So it's quite difficult. Sometimes you're in control rooms. That's a control room for a remotely operated vehicle that goes down to 6,000 meters, and we have all the instruments around. It looks like a control center from NASA or another space agency. We have all the instruments there. It's very exciting. We have, for example, a camera that shows some animals. We have a sonar, navigation display, the software, the chief scientist who is looking at the whole watch, the pilot, the technicians, and it's the size of 2 containers bolted next to each other. One container is full of equipment. The other container, you have all the display screens, and you are 8 cruisers' friend for the next 4 hours or more if things go wrong. And you're going to see them every 4 hours. So you have a shift, then you have a break, then you have another shift. And that's going to be like that for 2 months. If it works well, you make friends for life. Other times, that can be a bit more interesting, let's say. But so you're in very close quarters, and that's not something I'm used to from my holidays. We can have small boats as well, like this, again, with the glamorous suits, with equipment to deploy. In some places, I've seen in the Pacific Ocean, people get flown over by flying fish, and I've had a colleague who was actually knocked over by a flying fish, and it took 10 minutes to revive him, say, hey, are you still alive or not? Other places, we have to watch out, for example, for the icebergs, because they can actually bump against the inflatable parts of the ship and sink everything. So it's not that exciting. But what is exciting is the science we make out of it, and we can listen to these sounds. The way we listen, well, we can listen to them the traditional way, but what we can do is analyze them. For example, as a function of time, we analyze all the different frequencies we have in the sounds. This is a spectrogram, and that's a spectrogram of a whale. So we have the vocalizations of the whale, and more vocalizations there. And this is the traditional whale sounds, not even processed in that case. That's really the raw sound. Some of these whales have very complex communication strategies. They talk to each other. Some of them have some kind of a grammar or syntax, where we know, for example, with killer whales, they announce first which pod they are from, then who their mother is, and their sort of name, and then the rest of the communication. So there are still lots of things to discover there. The sound of a whale is going on for minutes and minutes and minutes, so I carry on talking. But we have the sound from ships. In that case, it's much more boring. It's like listening to a truck passing by. We're going to hear the propeller waves of the propeller moving around. That's going to create different harmonics. And that can interfere, of course, with the noise from the waves, but it's much less interesting. In some places, we have earthquakes. So they're going to be very short. It's like a rumble. It's a bit like an earthquake on land, if you have ever experienced one. So you hear everything rumbling, and that's exactly the same thing. One thing we noticed in north of Norway with data from an observatory is sometimes the waves are very chatty just after an earthquake. We don't know if it's to ask, are you okay? Or did you feel that? Oh, that was a nice wave. Or it's totally unrelated. We have no idea. And it's not part of our research. I'm afraid someone else will have to find the answer. But all these different spectrograms allow us to identify the different types of sounds. And what we do is, for example, we can look at glaciers. This is a glacier in Svalbard. You can see part of glacier falling off there. The part here is around 40, 60 meters above water. So we have around the same amount below the water. And this wave there is going to propagate up to the coast. So that's going to create coastal erosion. We're going to have a lot of sound. So usually this is a loud bang when it starts melting. We have blocks of ice. And we can hear it above the water, but we can hear it underwater very well for large distances. When these waves come in on land, they can actually create mini tsunamis. That has created accidents in some fjords in Alaska or other places where they have destroyed fishing boats or jetties. Nothing too serious at the moment. And that's quite impressive. I was caught in one of them once. We're on a small boat somewhere around there, and we're just hearing the regular bangs and thinking, oh yeah, nice one. Oh no, nothing this time. And then there was a big one coming in, and by this time we were very close to the shore. Our job was to replace the batteries on some cameras that were on the shore, looking at this glacier in stereo. And because I was both the youngest and the tallest of a party of three, I was the one jumping out of the boat and carrying everybody on dry land so that they could step out of the boat. So the water was maybe that high. I had water to my ankles. We heard the bang and say, oh yeah, nice one. Oh yeah, good wave. And suddenly all the gravel was sucked under my feet. So I was clinging to the boat. And then I saw a 2-meter wave coming in with what we calculated afterwards was a 15-ton iceberg. And it crashed just a few meters from us. Some people say, oh, it must have been frightening. Well, actually, no, we felt really vexed because as scientists, we should have known it would create a wave and that this wave would amplify in shallow water. So we felt really stupid. And yeah, very lucky as well, because if it crashes, even on one part, it can actually destroy, well, it can destroy us. It can destroy the equipment, even worse. Or destroy our recordings. It can destroy the survival equipment you have, the rifles, the flares, the radio, the emergency rations, everything. So there are lots of things to think about, but our job was to actually listen to the sound underwater. And this is what it sounds like. It's not very exciting. We're going to hear a track there. The image there shows the spectrogram for how loud some frequencies can be. So this is just a crack in the glacier, where there are more cracks, and then a block from the glacier falling off. This block is going to come back to the surface. going to rotate and create more impact. And all the noise we hear all around is the noise of the ice bubbles in the small ice blocks coming from the glacier, and the noise they make as they melt. So that tells us how fast it's melting as well. And that means that we can deploy hydrophones at the bottom of the water to actually monitor these glaciers, even if we're far away, even if the weather is bad, even if we're doing something else in another part of the Arctic. We can find out what these blocks are. We know how to calculate the volume of ice that has melted, how often it has melted. So we can use that to really see the impacts of climate change, just from the sound underwater. In other studies with the same team, so Oskar Glowacki in Poland, other people in Poland, and Grant Dean in the US, we have done studies with stereo imaging, where we can actually find out whether it's the glacier in front of us and which part, or the glacier behind us. So we can really find out what's going on. We have other types of sounds. The ice, so we have the normal ice from glacier, or what I call the normal ice, because that's what I work most with. But we have the pack ice, which is seawater ice, no bubbles. And that's going to create different types of noise as it moves with the waves, as it's being bumping into each other, all sorts of things. And that depends on whether we have new ice, like this one there, which is going to create loud noise and a big background there, or if we have thick ice, like the one we're going to listen to. So that's the sound underwater from some of the measurements we have from Canada. And it's like that for months and months and months. So what we have to do is find a way to measure it. What we often do is use things like the sound pressure level, so how loud it is over a range of frequencies, the sound exposure level, how loud it is for a particular period, so we can compare that with how the animals are going to be affected. The power spectral densities, which are actually how frequent different frequencies are. In that case, we can see what happens in different places at different seasons, whether we have ice, no ice, whether we have ships passing by, all sorts of things. So we're doing lots of measurements to understand what's going on. In that case, that was from a community observatory in Arctic, Canada. But we have other deployments elsewhere. For example, our Norwegian colleagues have deployed instruments in the Arctic for the last 5-10 years with lots of success, trying out different technologies. This program, Jonathan, right in the middle, is working on this data right now. So he's going to tell us more, maybe at a future talk, about what he finds out. But we have technologies to drill through the ice or to move around the ice, radio the data or send the data to different places. And that's part of a big Horizons project. So that's projects from the European community. The one we had was funded from January last year for 5 years. Because of Brexit, I couldn't be funded. So I was part of a project. Everybody wanted me in. It took several months of negotiations. I got a replacement fund. So that's good. I can participate, but I lost the first 5 months of a project waiting for everything to be signed in the UK. And we're not allowed to lead part of the projects. We're not allowed to sign the reports. Everything has to be signed by someone else who is in the EU. But the exciting thing is that we can actually measure climate change around the Arctic. So we have deployments coming up this summer around the North Pole. We're going to use one acoustic source which transmits sound every 3 days, just for a very short time. We're going to look at that to see how the oceans are warming up based on how fast the sound is traveling, how much ice cover we have. We have satellite images, but it doesn't tell us how thick the ice is. We're going to listen to all the sounds around. In particular, for me, that's going to be the sounds from shipping, the sounds from animals, or the bioacoustics, or the whales around, how they work, how they move, all these things. Other people are going to listen to the sounds from earthquakes and landslides at the seabed. We all have different tasks. Some people are going to look at the oceanography. Other people are going to look at the ice. We have several industry collaborators who are actually innovating and creating new things just for us to try out. They're very nervous because they don't know if it's going to work, but to go through the ice or stay in the ice throughout the year. So we're measuring climate change all around the Arctic Ocean using these sounds. For that, we're using artificial intelligence, deep learning, and all the amassed knowledge of people over the last 50 years about sounds in the Arctic. We have industry workshops where we talk with different industries to learn from them what kind of instruments we use, but to tell them this is what we need, this is the kind of measurements we need, this is the kind of thing you have to be aware of. For example, for ships, if you have a noise from a ship, but you reduce the speed, you can reduce the noise of a ship very well. That's something that is working, for example, in British Columbia, in the port of Vancouver, where they have a voluntary program where ships can agree to be monitored as they pass through a series of hydrophones. That gives them the acoustic footprint of a ship. But after that, they are told, okay, there is a pod of whales at this place. You have to go very slowly to avoid disturbing them or injuring them. Or there is nowhere around, you can go as fast as you want. So that's voluntary, but it's working very well. They have a 98% compliance rate. The industries are very pleased because it tells them how green their ships are or where they have to make efforts to reduce the loss of energy by making too much noise. The environmental people are very happy because it's protecting the whales and the local economy as well. And they're thinking about expanding that to other places as well. So we've been working on the different standards about how to monitor these sounds, how to measure them, so that everybody can compare what they have and know it's been measured in the same way, and we can trust the measurements. That's work I have done with British standards. British standards have been essential for creating the European standards. For example, the Marine Strategy and Framework Directive, which tells us how much noise ships or any activities can do on the oceans, is based on British standards. And I'm very pleased to say it's also based on research I've done with a previous PhD student about how to measure these sounds. And now we're working on the international standards. So that's work I'm doing with the International Standards Organization so that everybody measures in the same way. We have so these standards, these policies, but we have also, we're trying to federate the research from different groups. So I'm sharing the Arctic Acoustic Environment Working Group of the International Quiet Ocean Experiment. The International Quiet Ocean Experiment, at the beginning, was thinking about having one day with no noise in the oceans that we could compare the noise we make with the noise we don't make. Then they realized very quickly that it was not possible. No one would be able to comply. But we have different working groups looking at different aspects of sounds in the ocean. And what we have there is so people from all around the Arctic countries, so Norway, the US, Finland, Canada, Denmark, Germany is very active. So we're funded by the Scientific Committee on Ocean Research, SCORE, and the United Nations. And we regularly have activities, for example, to say, this is what we're doing, this is what we need to measure. That's what was used to create the essential ocean variable. So the sounds to say, look, this is really what we need to understand what's going on. We've been to conferences like the Arctic Observing Summit. It was very interesting because it's not really about the science, it's about using the science. And that was used as a precursor activity, in that case, to this Arctic Science Ministerial in 2018. Every 2 to 3 years, the Arctic science ministers of the different countries around the Arctic meet, and they decide what they have to do to make the Arctic a better place, to understand how it's changing. And for the first time in my life, I was part of a conference where I said, okay, these are the recommendations. And all these ministers listened and say, yes, you have to do what you're doing. So I love that. But it's part of a big dialogue between the scientists, the politicians, whoever makes all these policies and guidelines or decides on the funding, but also the people living in the Arctic. So the Arctic communities about, for example, what is useful for them, what is not that useful, what they're worried about. For example, I work with the Hunters and Trappers Association in Cambridge Bay in Canada. And that's very interesting. I was invited once to talk to the Council of Elders as well. And they don't really care about science or sounds or anything. They want to know, where is the fish? Is the fish going to be, because that's subsistence communities, where is the fish? Is the fish going to be moving with climate change? Is it going to be affected by the big cruise ships moving around? Some of these big cruise ships don't behave very well in that place. One of them parked in front of fish traps and stayed there for a week. So for a week, people couldn't do anything. In other places, they landed sightseeing parties on hunting grounds, scaring all the animals away. With climate change, they have issues. For example, the ice is changing in one of the bays nearby. The caribous are not migrating on the ice anymore. They are migrating further away, which means the hunters have to find out where the caribous are. Then they have to go and find them, which means more fuel if they're using a snowmobile, more pollution because the sound from the snowmobile travels through the ice into the water and affects the animals. It means more fuel coming back with the caribou. So all sorts of things. And it's thinking, okay, what is useful for you? What is useful for me? So it's co-creating, co-designing the science. And every local community is going to have different problems. One thing I learned, for example, in Canada, when communities are resettled in the Arctic because the coastal erosion or the melting of the permafrost means their community is not viable anymore, they're going to another community and they don't read the ice the same way. So they have lots of issues reading the ice, knowing when it's safe to walk on it or when you should avoid it. So there are all sorts of things we can do there. So in conclusions, well, the Arctic Ocean, even if it's far away, is a key component of the Earth's climate system. What happens in the Arctic is hitting us right now, but it's going to amplify over the next years, the next decades. And that's going to affect the effects of climate change, for example, monsoons, weather systems, ocean circulation. Sound is an essential ocean variable. We can use that to measure biodiversity, ice processes, whether the ice is melting or not, the type of ice, human impacts. We can use that with tomography to measure the changes of temperature, not only at the surface of the ocean, something we can do by satellite, but in the first 200, 500 meters of the ocean. So really how it's working. And it's very important to measure it now before it starts changing too much so that we can have a baseline against which we can compare things. We can say, well, the noise pollution has increased a lot, or actually, no, not that much. Or sounds from these ships is actually less noisy than the ice in which animals were living all year round. Or these types of fish and whales are moving in this place. The big thing is sometimes these animals are going to run out of roads because they won't find any cold water to move further north because of the warming of water from the equator all the way to higher latitudes. For example, there are animals like snapping shrimps that used to be just in the tropics, and now you can catch them in Plymouth or even Dover, and they're moving north as well. Salmons are moving north. I used to live in Seattle, as Stuart says, so salmon is everywhere, but actually it's disappearing little by little, especially in British Columbia. Part of it is the warming of the ocean. Part of it is the amount of silting and sedimentation of the rivers, the pollution. All these salmons are moving north. And I was talking to First Nations in Canada and others in Alaska. I think, wow, that's good if you have so many salmons. You must be very pleased. They say no, because they're equipped to deal with a particular type of fish. If you have canneries or fisheries, they are used to different types of fish. And suddenly, their main source of subsistence is disappearing, and they have to adapt, invest with money they don't have in all these places. So that's some of the things we have to think about. So we need to involve local communities to make sure that the science we do is not confined to the ivory tower of academia, but it's actually useful to people around the world. We need to measure and monitor in the best way. So we need to know what we're doing, compare with others, and that's why we have international standards. And then we need to adapt all these activities to make them sustainable. For example, shipping, I talked about reducing the shipping speed to make it less noisy, or just get out of the way as fast as possible if there is no endangered animal around. It can be rerouting shipping lanes. That's what they have done in the Strait of Kattegat between Sweden and Denmark. They did that because of the amount of traffic, but they realized all the good effects it had on the biodiversity. So it can be the animal impacts. It can be if you're using a ship, for example, what we're preparing this summer. Sorry, what we're preparing this summer. We're extremely careful about how long we're going to be in the water and how much ice we're going to encounter to make sure we don't change the environment around. So we're extremely careful about the animal impacts, but other people using the Arctic should be. Then it should be about the policies, making sure that we have guidelines that people can respect or they can follow, but it's policed or endorsed. And that's a big problem in a place which is still international, away from national boundaries. We have some international conventions like MARPOL that tell us we're not supposed to dump things at sea at a certain distance from a coast or only biodegradable material. But what about the sounds? What about other things that we're doing at sea? What happens if we are in international waters? So we need more international policies there. So I'll stop there, advertising shamelessly the YouTube video that university made about this research. And thank you very much.
Thank you very much. I'm happy to answer some questions.
Of course.
Who'd like to begin?
Thank you. I'm Peter Ford. It's more a comment that a few months ago we had a very interesting talk here about Franklin, who tried to discover the Northwest Passage in the last century. And amazingly, the BRLSI has some artifacts which belong to Franklin, which were done at that expedition. And presumably, if a Northwest Passage can be discovered or produced through climate change, it's going to change the sort of dynamics of international shipping quite considerably.
Yes, definitely. That's something we have, for example, at the border between Greenland and Canada, where Canada claims some of these waters belong to it and Greenland doesn't. So sometimes we have issues with shipping there. During COVID time, I remember one case of a sailing boat full of Danish Hells Angels who decided to go sailing the high seas like their ancestors Vikings and landed in a small community in Arctic Canada. And they made friends very quickly by asking where the drugs and the women were. So at that time, it was still possible to get the Mounties, and they deported most of the ship. And everyone said, oh, at last. And the Mounties came back and the next day and deported the rest of the ship as well, because all of them had criminal records and everything. But that's one of the issues, is sometimes you're in great territory, you don't know who is allowed to do what. Some of the cruise ships, they have an international polar code of conduct, but not all countries do that, or not all companies want to respect it. For fishing, I saw an article recently, so big vessels should have an AIS transponder, automatic identification system. And that tells everybody where they are, what they are doing, at what speed they are, and so on. And in the Northern Pacific, lots of these ships suddenly have malfunctions just as they enter a marine protected area. And the malfunction stops 2 weeks later when they're suddenly on the other side of the marine protected area, heading back to port, where there are records of how much fish they cooked. It's very weird. It's just lots of malfunctions. So there are lots of issues there, and that's going to increase as we have more people, more shipping in the Arctic, indeed.
Thank you, Philippe. You mentioned the fish moving, the salmon moving north. I just wondered in general, do the nutrients and the food sources for the Arctic animals increase with climate change, or are they decreasing?
Not that I know. The central Arctic, the place away from the continental shelves, is very poor in nutrients. That's why we have very few animals. Right now, for work I'm doing, I'm counting the number of whales per square kilometer, and that's very, 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 very small. But other animals as well don't use the central Arctic that much. All the nutrients are concentrated in shallower waters around the continental shelves. We don't see any changes yet in the nutrients, but we see changes in the populations of animals because of warmer water elsewhere.
It's bad for the reindeer.
Well, it's bad for reindeer, yes. It's bad for reindeer herders because there are all sorts of other conflicts, all sorts of things, yeah. Alison.
Oh, sorry. The North Atlantic Oscillation, I seem to remember that's been in the news recently. I don't know whether you talked about the currents. I mean, are you able to observe much about these changes?
No. My colleague Hannah Sagan in Norway is actually doing that. So she's the expert on Fram Strait. She's deployed lots of instruments. She's coming to Bath for the big international conference we have in June, where she's giving the keynote speech, so you can ask her directly then. No, we see some changes, but at the moment it's part of the fluctuations around. Personally, on a totally unscientific basis, I'm a bit skeptical of all these claims. I started hearing them in the early 90s. The Gulf Stream was going to shut down, it was going to be catastrophic and everything. And I said, well, actually, we're not sure. Oh, no, we have more data. No, maybe not. Oh, not yet, next year. And if it's been happening for 25 years, okay, it might happen at some point, but at the moment, we don't have the data to be specific about what's going to happen.
Can I ask another unrelated question? What about politics? Do you get problems with the submarines? Because they're the nuclear submarines. They want to creep under the Arctic ice, if I recall.
Yes, submarines are using the ice cover a lot. It's very interesting to see how they work. For example, they want to know more about the ridges below multi-year ice because that's where they can hide from other submarines, or it's affecting sound propagation in different ways. I personally haven't had issues with submarines, and that's all I can say. Other questions?
Just thinking about the nutrients at the base of the food chain in the Arctic, I imagine that quite a lot of those nutrients come into the Arctic Ocean through the rivers that disgorge into the Arctic Ocean. Are there interesting changes going on in that area
yes,
too?
some of these rivers are going to carry more fresh water more often, so they're going to have higher rates. They're going to erode more, carry more sediments as well. Some of these rivers have radioactive sediments in some parts of the Arctic, coming from the disposal of submarines in other places or from other things. But it can be pollution from mines as well. Some of the coastal countries are going to have melting of the permafrost, so they're going to have methane emissions. And there are methane hydrates at the bottom of the ocean. At the moment, they are locked because of the low temperature. So there are sediments containing a lot of methane. And it's very nice because I've seen videos of people taking them. It looks like a big snowball, a bit dirty. And they take a light and it all lights up. So it doesn't hurt them, but there is a lot of gas trapped in there. And at some point, if the oceans warm down to these levels, that's going to release all these greenhouse gases through the water and in the atmosphere as well.
I was wondering if this approach using acoustic data is generalizable to the marine environment as a whole rather than just the Arctic. Are there other
Yes.
applications that it can be used for?
Yes, or we use it in other places. Like anything else in research, there is more being done, or there has been more being done in the tropics, where you have warmer waters and it's easier to measure things. But for example, I work with Ocean Networks Canada, where they have observatories all around Canadian waters, so in the Pacific, in the Atlantic. So we can hear different types of whales, different types of animals. We can hear hydrothermal vents, volcanoes. Very often these sound monitors are coupled with cameras, so you can see what kind of animals are actually visiting. Sometimes very cool because you can see the camera and you see the animal just bumping the hydrophone. So messing with the data, but at least you know who is there and what you're listening to. So this approach has been used in all oceans around the world. There is a program called LIDO, Listening to the Deep, by my colleagues at the University of Catalonia, Michel André and others, where you can access on the web recordings from all sorts of animals from different observatories around the world. The Alfred Wegener Institute in Germany now has a program called Opus, which is an open portal for underwater sound. They received their funding last year and they have the first data sets online. So you can listen to the animals that interest you directly from the database. So we use that a lot. The issue is how much data there is, whether it's calibrated or not. That's always the issue with older data. And then what do we want to know? Very often we don't know the questions we want to ask. Does that answer your question? Yeah.
Philippe, in the oceans in the rest of the world, fish are gradually disappearing. We all go to Sainsbury's and find that fish is much more expensive than it used to be, and that's because there's less of it and there are more people who want to eat it. So there are all these fishing boats in the world chasing fewer and fewer fish. Is it possible that they can be kept out of the Arctic?
Out of national waters, it depends on the countries. It depends on what kind of regulations they have. It depends on what kind of enforcement they have. Because that's what people saw in the North Pacific. Some countries don't have the means to enforce the big fishing fleets from another country or from a big company coming, harvesting anything and leaving with there is no fish left. So that depends on the enforcement capabilities. Fishing in the Arctic, well, anything in the Arctic is still very dangerous. And it's very expensive for fishing. So it would be big countries, big companies who would be able to do that. But at the moment, there is nothing to stop them. They might have coast guards from one country or the other, but coast guards very often don't have enough ships in the Arctic waters.
Fishing in general is done over the ocean shelf rather than in the deep ocean, which is a bit of a desert. So we're talking about fishing around the edges of the Arctic Ocean, which are already ice-free for a considerable part of the year.
Yes, they are.
Is it already the case that there are fishing fleets fishing in the Arctic?
There are fishing vessels in the Arctic. They're indeed confined to the shelves. I have data on my desk, so it's still a few dozens of ships from the local communities, so it's not that big at the moment, but we're afraid that it might become a bit less manageable in the future. In Western African communities, some communities were prevented from fishing because big fleets came in, got all the fish they had close to their shores, so they couldn't go out with their normal canoes or small boats. And then the fish and the fleets moved out further out on the continental shelf, where the local communities don't have the boats or the money to go to get their food. So they've been priced out or harvested out from their traditional fish. And that's an issue, for example, in Arctic communities as well, where it might happen too.
Thank you. I just wonder whether what's the state of the ozone hole at the moment? Presumably it's mostly healed from the problems we had a few decades ago, but I just wonder if there's any interaction between what's happening now in the Arctic and the effects on upper atmosphere and ozone.
There are links between the oceans and the atmosphere, of course,
Yeah.
because, so for example, the winds are increasing in the Arctic. The ozone is more about the type of vegetation, so how affected it is by UV light. The life is not affected as far as I know. It's more the winds, the fact that, for example, the ice is melting, so we have more black rock or soil being exposed. So that's going to reflect more energy back into the air. We have, in there are places in Svalbard, it was very impressive to go there at a 7-year interval, where suddenly lots of places had no snow at all. So you can really see it with your naked eye.
Well, I did hear of one problem with an animal species in those regions and the ozone hole. Apparently the North American walleye, which I think is the equivalent of our pike, hunts in shallow water, and they've had to develop a chemical change in the mucus on their backs to act as a sunscreen to stop them getting sunburned.
Okay.
And it's actually changed the color of the fish from yellow, which is it was known as a yellow fish, to blue. The mucus has changed to blue.
Okay, well, that's interesting. I didn't know about that. Thank you. But yeah, so that can affect other animals indeed in different ways. It's like the winter fur or summer fur for Arctic foxes, for example. Is it going to match the kind of snow or non-snow they're going to have? That's a big issue for Arctic foxes. First, because I find them very cute. They are very small. Second, because each time I saw them, they were getting beaten up by the geese, who are much bigger. So I want to give them a fighting chance.
Well, if there are no more questions, I think that I'll simply call on you to thank Philippe for a terrific talk and for giving us lots to think about the Arctic and what it means to us.